so now we're making v the subject. Notice that v is part of this fraction here. Again, perhaps I could make one single fraction out of this, but I think I'm going to go ahead and actually get rid of the k. So thus, for a reminder, let me just use the balance method. So I'm going to subtract mg here on both sides, like as I did in the previous question, simply because v is part of this fraction, just like r is part of this. So this cancels out. I'm left with p minus mg equals mv squared all over r. Now the reason I was able to get rid of mg, because mg is actually added to the entire remaining expression, right? Mg is added to mv squared over r, which is a fraction. So whatever is affecting everything else, we can actually remove first. And that's something we want to also bear in mind. Okay, so now we have mv squared over r. So bear in mind what we're trying to do. We're trying to get this v by itself. Okay, so if you look at it this way, that, well, we could actually think about transposing, but I'm not using that method. So I'm going to actually do is to make p minus mg a fraction by putting it over 1. And since what I'm trying to find is in the numerator, which is mv squared, where the v is there, I'm going to actually multiply 1 by mv squared, so I can actually get the v on the left hand side. So cross multiply. Again, I can only cross multiply because I have an equal sign. Now I'm going to multiply r by p minus mg. R times p minus mg. In fact, I'm going to leave it like that. I'm not going to multiply it out. Now what I'm trying to find again is what? Yeah, I'm trying to make v the subject. So I look at how v is connected to the other variable, which is by multiplication. In fact, v squared is connected to m by multiplication, not just v, but v squared. So I'm going to try to get v squared first off, isolated, and then I can remove the square. So v squared is connected to m by a multiplication. So I can get rid of this m by division. And I do that to both sides. Divide both sides by m. So since I'm actually multiplying in the numerator, m times v squared, then this m can cancel m in the denominator, and I'm left with v squared is equal to, in the numerator, r times p minus mg over m. Now to get rid of square, what do we do? Well, do you recall that to get rid of a square root, we use square? Well, to get rid of square, we use square root. So I'm going to square root this side, and I'm going to square root this side as well to keep it balanced. But the purpose of square rooting this side is so that the square root cancels out the square. I'm left with v, and so v is equal to the square root of r times p minus mg over m.